Hi, my name is Steve Bertolani, and today I'll be telling you about RelationalAI, a native app on Snowflake that allows you to build intelligent data applications. As the world increases in complexity, we need to leverage AI solutions in the enterprise. The combined power of Snowflake and RelationalAI offers a simplified, cost-effective path to advanced enterprise AI capabilities. Whether you're modernizing an existing system or building new enterprise AI applications, this is now possible directly within Snowflake, leveraging native apps and Snowpark container services. RelationalAI and Snowflake have helped our customers build and modernize sophisticated applications, adding intelligence while reducing code and complexity by tenfold. We do this via a data-centric architecture based on relational knowledge graphs. As a Snowflake platform extension, RelationalAI supports compound AI workloads for rules, graph analytics, prescriptive analytics, and soon predictive analytics in Snowflake. Here is an image from Gartner that demonstrates the Berkeley AI Research Group's take on what AI techniques the enterprise will need for the next generation of intelligent data applications. This view includes graphs, logic and rules, and several forms of prescriptive and predictive analytics. At RelationalAI, we believe in order to build the next generation of intelligent applications for the enterprise, you will need all of these capabilities tightly integrated with your data cloud provider. The next part of our offer to the marketplace is our deep integration with Snowflake. Unlike legacy solutions, RelationalAI is cloud native and has all the advantages of Snowflake, including versioning, zero-copy cloning, scale, and consumption-based pricing. When we call ourselves a coprocessor, we mean it in the same way that some matrix operations are offloaded to a GPU to augment the CPU. If your data is on Snowflake and you need to support adding graph algorithms, predictive analytics, or other AI calculations, you can just add the RelationalAI chip to your stack, and you get all the same governance, safety, and paradigms that made you pick Snowflake in the first place for your data cloud needs. Your data stays where it is. Our technology is based on the ability to create knowledge graphs that provide a model of the organization's business. Let's take a quick look at those. These are really just a technical way to describe your business domain. Here we are looking at a conceptual map of one way to think about a business that creates POS software for food trucks to run their business. In this business, some of the key concepts are customers, trucks, transactions, and communities of customers. In the example I'm going to show you in a minute, we will use a combination of rules and graph algorithms, plus this knowledge graph schema to identify relationships between customers in a retail example. We cover many different workflows and domains. If you see your domain or problems on this screen, consider taking a closer look at us. Okay, with that, let's show you a demo of what it looks like to use RelationalAI's native app integrated with Snowflake. One way to get started is to head to our website and go to the documentation and resources that will help walk you through the setup process of installing the native app. In addition to that, we have a number of other resources to help you get started developing with RelationalAI. Let's go to our example notebooks. And here we see different options to get started. We have both simple start notebooks, as well as notebooks that will run on the Snowflake notebook environment. For today, we're going to take a look at doing community detection with the Tasty Bites dataset. Okay, now let's open our community detection notebook. This notebook walks through a use case using a fictitious dataset provided by Snowflake. The data is about a fictitious set of food trucks who all use the same POS system, and therefore there's a record of all the transactions that happen across the system. We'll take those transactions and infer complex social groups based on some rules and graph algorithms. Then we'll be able to visualize the results. You can interact with our system in one of several ways. Here we'll show you what it looks like to run a Jupyter notebook on a local Python environment. The first thing we'll need to do is to import our RelationalAI Python package. Then we'll create a model object. The model object is both a container for our objects, as well as any rules or logic we add. Because of our tight integration with Snowflake, all we need to do to access the data is to point our models to the table or tables we want to operate over. Here we'll give our model a pointer to the Snowflake table we will use the data from. We can now run a simple query to verify the data view is working correctly. In this example, if we take a high-level view of the important components that we want to operate over, we might come up with a list of the following crucial parts. We will want types to model the customers, the trucks, and the transactions. And later, because we'll be finding communities and filtering them, we'll also add a couple of additional types to our model. We can always go back and add more if we need. In order to add data from our table to our model, we'll just need to define a rule to tell the system how to populate customers from the table. Here, we'll use the unique customer ID to identify a customer. And then we'll do the same thing for trucks. Finally, we uniquely identified the transactions by the following information: customer ID, order ID, truck ID, as well as the time and location. In this example, we have a bunch of transactional data that we want to use to extract social networks amongst customers. Here we write a rule that says take two transactions. If they happen within the same 20 minutes at the same time and place, keep it as a potential connection between the customers. The intuition here is that if you go to lunch with your friends, then you'll likely order around the same time. That simple rule allows powerful inference in this data. Now we have to create an object to store all these potential connections between people who stand in line next to each other. But there's no guarantee that it didn't just happen spuriously. Perhaps you just happen to order coffee in line right behind another parent that you don't know. If that's the case, we can add a simple filter to remove these spurious connections and store the filtered connections as part of our relevant connection object. Let's see that here. Let's take a pause and look at what we're doing. All of the code we've written so far has essentially been to write different logical rules and attach them to our model. We said things like, let's populate the customer data this way, let's populate transactions this way, let's filter those transactions down to pairs where X, Y, and Z are true. And in this rule, we're saying, of the connections I found before, let's make sure they happen more than once, or in this case, more than 4 times, to be sure that the resulting social graphs show strong relationships. And here we get our final count of the number of relevant connections we have derived from our data set. Now that we've added all these rules to our model, we can simply tell it one additional rule on how to construct a graph and which data to use to do it. Here we specify that the nodes should be customers, and the weight of the edges in the graph should be the number of times 2 customers were seen within 20 minutes at the same time and place ordering food. Let's write one final rule that says I want to use this graph to run the Lubin graph algorithm. This will basically give each group of friends a unique identifier. And now it's time to plot the results. Here we are plotting our social customer network graph. Every subgraph indicates a separate social network. Here we see coworkers who lunch together, friends who meet up for dinner, and other close-knit social groups. Suppose we're interested in a particular customer, or we want to see how big the social group is of that particular customer. We can search through the data to get the community ID that was assigned to that customer, and then we can recolor the graph. Zooming in, it's now very easy to find that particular social group. Remember, here we're seeing the nodes are identified by the customer IDs, and the edges between nodes show the number of times 2 customers ordered food at the same food truck at the same time and location. With RelationalAI's native application on Snowflake, this type of graph analysis, as well as other types of AI techniques, are available at the click of a button. Thanks again for joining this demonstration of RelationalAI's Knowledge Graph Coprocessor for the AI Data Cloud. To learn more or to get started, we encourage you to head over to the Snowflake Marketplace today. Up next, we invite you to hear firsthand how organizations like yours are leveraging our Snowflake native app to solve real business problems. In this replay from Snowflake Summit 2024, you'll hear from Christian Figueroa, Head of Network Science and Behavior Modeling at Cash App, as he sits down with Snowflake's Amanda Kelly to discuss how their team leveraged our graph analytics solution via Snowflake Marketplace for customer behavioral modeling. Thank you.